We're going to finish up our unit on differentiation with one more rule called the chain rule. Now, previously we've been able to differentiate different functions. If you look at the first one here, f of x is equal to x squared plus 1 times 2x cubed plus 2x, that we can do with the product rule. So that's no big deal. But take a look at the second one here. This one has a polynomial raised to an exponent, and we can't really do that easily. We could write it 4 times and use some crazy, different, and distribute, and then use the power rule, but that would take quite a bit of work. So for this one, we're going to introduce something called the chain rule to help us out. The chain rule relies on our knowledge of composite functions, and we talked about composite functions very early in the year. One way to represent composite functions is to say f of g of x. So we have an outside function and an inside function. For example, if I'm given f of g of x is this expression here, x squared plus 2x raised to the 5th power. I know I have an inside function, and that would be x squared plus 2x. And then my outside function, we used to name it as x to the 5th, because the outside function is what you get when you replace the inside function with x. So when we use the chain rule, we're still going to identify inside and outside functions. The only difference is we're going to be evaluating the function at the same time that we are taking the first derivative. So our outside function, we will never see that variable x. And that's what we have to be careful of when we talk about the chain rule. So here's the meat of the chain rule. In symbols, it says if I have a composite function, y equals f of g of x, then the derivative of that is going to be f prime of g of x times the first derivative of g of x. So it's the derivative of the outside function evaluated at the inside function. So it's not the derivative of the outside function with its variable. And then when you take that, after you find the derivative of the outside evaluated at the inside, then you multiply by the derivative of the inside function. It's a little difficult to explain in words, so the best way to show this is to do some examples. So here we have our first example. It says if f of x is equal to 3x squared plus 2x plus 1, that entire polynomial expression being raised to the 4th power, I want to find the first derivative of that. Well, I can break this up into 2 functions. I can have an outside function and an inside function. It's pretty easy to recognize the inside function. That's going to be the polynomial in the parentheses. So inside we would have 3x squared plus 2x plus 1. So that's going to be our g of x. Outside would be the function that we would get when we replace that polynomial with an x to the 4th. However, when we use the chain rule, we're going to take the first derivative, but my first derivative of the outside function is not going to be 4x cubed. It's going to be 4, and then instead of an x, we are evaluating it at the inside function. So you won't see a separate 4x cubed in your problem. Let me show you that. So we have f prime of x, using the chain rule, is going to look like this. It's the derivative of the outside function evaluated at the inside function. So if I look at x to the 4th, I know using the power rule, it's going to be 4x cubed. But instead of the x, I'm evaluating it at the same time at the inside function. So I have 4, and then I have 3x squared plus 2x plus 1. I'm kind of differentiating around the inside function, multiplied by the derivative of the inside function. The inside function is 3x squared plus 2x plus 1. So I'm going to use the power rule on those terms, and I get 6x plus 2. So again, looking at this, the chain rule. If I have a composite function, it's going to be the derivative of the outside evaluated at the inside. That's all this right here. Multiplied by the derivative of the inside. And then we use whatever algebra skills we need to simplify. In this case, the only thing I'll do is distribute the 4 into the 6x plus 2. So my final first derivative is 24x plus 8. And then that's multiplied by 3x squared plus 2x plus 1 raised to the third power. So let's look at a second example. This time I'm going to use a transcendental function. I have y is equal to the sine of x squared plus x, and I want to find the first derivative. So looking at this, we know our inside function is what's in the parentheses, so I can label it as x squared plus x. The outside function would be sine of x. But again, I'm not going to see this x in my answer because I'm always evaluating the outside at the inside when I take the first derivative. So here we go, dy dx. Dy dx is equal to the derivative of the outside. The derivative of sine is cosine. Evaluated at the inside function. The inside function is x squared plus x. And then that expression is multiplied by the derivative of the inside, which is now 2x plus 1. In this case, there's not much I can do to simplify. I am going to put the binomial in front, so it's going to look like 2x plus 1 times the quantity, or times the cosine of x squared plus x. The last one we're going to look at is one that has a coefficient in front. So if I think about 2 times the cosine of x, well, my original function is 2 cosine of 3x. So let's first write down the inside and the outside. The inside function would be 3x. The outside function would be 2 cosine of x. So if I look at 2 cosine of x, that can be treated as a product. And if I think about what that product is, and if I apply the product rule to this, that would be u of x would be 2, v of x would be the cosine of x. Well, if u of x is 2, the first derivative of 2 is 0. So I really don't even need to apply the product rule here because the first half of it is going to be 0. So the second half would be 2 times the derivative of cosine. So when you have a coefficient with another function, that coefficient just stays with it. It's along for the ride because had you used the product rule, the first half of it would be 0 because the derivative of any constant term is 0. So when I apply the chain rule here, I get f prime of x is going to be equal to the derivative of the outside function. That's going to be negative 2 times the sine, but instead of sine of x, it's evaluated at the inside function. So it's negative 2 sine of 3x. All of that is multiplied by the derivative of the inside function, which is 3. So in the end, f prime of x is equal to negative 6 times the sine of 3x. And what we will do in class is work several more examples where you can kind of see the patterns and see all the different types of functions that we can apply this to.